Welcome to this web seminar, An Introduction to Microchip Development Tools. My name is Daryl Johansson, and I'm a manager in the Development Tools group at Microchip. The centerpiece of our tool set is the Software Integrated Development Environment, or IDE. MPLAB IDE has enjoyed many years of evolution, tracking Microchip's popular catalog of microcontrollers and digital signal controllers. This presentation will cover these topics: a look at MPLAB and its components, an MPLAB IDE overview, MPLAB's hardware components including MPLAB starter kits and demonstration and evaluation kits, and finally we attempt to answer the question, why use Microchip tools? To reach the largest possible audience, MPLAB IDE runs on 32-bit Windows computers. It has hardware and software component tools and is free. It can be downloaded from our website. The components of MPLAB are hardware and software tools that assist in the creation, design, and implementation of embedded systems using Microchip microcontrollers. The MPLAB integrated development environment can be viewed as a platform for the rest of the Microchip technology tool set. Using a singularly straightforward graphical user interface for design, debugging, and programming helps you get your applications finished fast. MPLAB's Programmer's Editor is for writing and editing source code. The editor recognizes C programming constructs and automatically uses different colors to identify comments, labels, and reserved words to help you quickly spot syntax errors. It has advanced features such as bookmarks, block indent, brace matching, and block comment uncomment. The source level debugger drives software or hardware debuggers as your application executes. The capabilities of the software or hardware debugger may differ slightly among the various debugging tools, but breakpoints, stepping through code, and access to variables and registers are the same. This provides an easy learning curve when switching from a simulator during early development to an in-circuit emulator when the hardware is functional. The project manager lets you create and associate source files with the compilers, assemblers, librarians, and linkers to build your final application. All the language tools operate seamlessly when you build a project. Click on Compile or Link Errors to bring up the source code window in the Programmer's Editor on the line with the error, so you can quickly fix the problem and rebuild it. Breakpoints and single stepping through your code uses your original source files, so the editor, debugger, and project manager work together to help you fine-tune your application. Software components for MPLAB include both free and for-sale versions of Microchip compilers for PIC microcontrollers and dsPIC digital signal controllers. These are optimized, ANSI-compliant compilers that integrate directly with the project manager. MPLAB IDE provides graphical dialogues to set up memory models, optimizations, and control compiler preferences. Many third-party vendors also provide software development tools that can be integrated into MPLAB IDE. Check our website for a directory of these manufacturers of software and hardware tools. These tools include real-time operating systems, language compilers, and lint checkers. Third-party version control systems are easily integrated into the MPLAB IDE, so all your editing can be done here. Third-party components in this diagram are colored light orange. MPLAB IDE includes free simulators for all PIC microcontrollers and dsPIC signal controllers. Simulators are software programs that mimic the operation of a microcontroller, simulating PIC and dsPIC instruction execution, responding to stimulus events on pins or registers to verify that code is operating as expected. With a simulator, you can test and debug much of your software before the hardware is ready. You can also measure the duration of code execution to help you evaluate and optimize your routines. A couple of third-party simulation tools are listed here. Lab Center's Proteus combines fully interactive mixed-mode SPICE circuit simulation with detailed hardware level models of the PIC micros to simulate and debug complex digital and analog designs. Device blocks for DSPIC devices allow MathWorks MATLAB to be used as an additional tool extension. Hardware debuggers can halt program execution in the application, so you can inspect internal registers and single-step through code in a prototype or final hardware. In-circuit emulators can measure code execution times, halt on complex series of events to find subtle bugs, and can trace the execution of code as your application executes at full speed, so you can track program flow. Microchip offers in-circuit emulation with MPLAB RealICE. Programmers are the last link in the chain. Programmers are used to embed the finished code into the PIC-Micro or DSPIC so that the target application can run on its own. At that point, the development system tools have finished their work, and you can begin evaluating your application as it operates in its final form, completely separated from the development environment. Microchip's top-of-the-line programmer is MPLAB PM3. Combining capabilities of both hardware debuggers and programmers are in-circuit debuggers, or ICDs. These have many of the tools found in more expensive emulation systems while providing programming features as well. The low-cost PIC kit does hardware debugging and programming on a budget. While not as powerful as an in-circuit debugger and emulator, code can be run and halted and registers examined and modified to fine-tune an application. And the final circuit can be programmed using Microchip's in-circuit serial programming interface. MPLAB starter kits offer very low-cost, easy-to-use application demonstration with built-in hardware debugging and reprogramming facilities. Third parties also offer emulators and hardware debuggers that work with MPLAB and a wide range of programmers, from large gang programmers to budget systems for hobbyists. MPLAB IDE can be expanded with other associated tools to be incorporated on the MPLAB desktop. Application segment tools such as motor control development, bootloaders, a sophisticated data monitor and control interface, RTOS viewers, and other components can be part of the MPLAB development desktop. Let's take a quick look at MPLAB IDE. MPLAB's desktop looks like many other Windows applications. Pull-down menus at the top allow access to all the features of MPLAB. Toolbars provide quick access to the most common functions with easily identifiable icons. The debug section of the toolbar allows running, stopping, single-stepping, and resetting the processor with a simple click of the mouse. At the bottom of the MPLAB desktop, the status bar displays the current operating debug tool, the processor supported, and important debug information such as the program counter, processor flag status at breakpoints, and system clock frequency. In a typical debugging session, you have immediate view of all the information on your project setup. You have instant access to all source files in order to edit your code. And while debugging, you can see data and code in your application in various formats to help debug and optimize your design. Breakpoints and single stepping can be done in source code windows, in machine code views, and in mixed C and assembly views. Trace buffers record and analyze your code so you can view and track program flow. Data and watch windows display current I/O, variables, arrays, structures, and register contents at a glance. The color-keyed editor makes source code debugging easier. You can set breakpoints with the click of a mouse in your source code, hover the cursor over the name of a variable to see its value, and customize your watch windows to view and modify registers and memory. Other free tools are available that work in conjunction with MPLAB. These are available for download from our website. Digital filter design is made easy with our filter design package for the DSPIC devices. A TCP/IP stack is available for connectivity applications. DSPIC Works provides a variety of 32-bit floating point or 16-bit fractional signal generators, has powerful arithmetic and digital signal processing tools such as FFT, convolution and correlation, sample rate conversion, and digital filtering. It can display data in a variety of formats, as charts, graphs, and with three-dimensional plots. Files can be imported and exported to MPLAB. A host of software libraries exist for C and assembly language programming. And more software is coming. Check our website for the latest information. We've briefly discussed the Project Manager, Programmer's Editor, Language Tools, and Simulator as the major software components of MPLAB IDE. This section will introduce some of the hardware components. PicKit 3 is one of our most affordable hardware debug systems. Its low cost makes it a perfect tool for school labs, hobbyists, or developers on a tight budget. It is USB connected and powered, connects to the target with a simple 2-wire interface, is very low cost, but offers full-speed, real-time emulation with standard MPLAB debugger functions such as run, halt, single step, and breakpoints. It can be used as a programmer for most Microchip flash devices using the in-circuit serial programming protocol. The MPLAB ICD3 price performance is a great deal and can be used to develop for most any application using 8, 16, and 32-bit PIC microcontrollers or digital signal controllers. Its high-speed USB interconnect provides power to the unit, and it has robust clock and data line protection. A test interface module is included to verify that all lines are operational. It has standard MPLAB debugging features, complex breakpoints, plus a stopwatch, and for selected devices up to 1,000 software breakpoints. MPLAB RealICE provides the ultimate solution for hardware debugging, providing complex breakpoints, real-time data watch points, trace facilities, and an I/O interface to synchronize with other instrumentation. MPLAB RealICE provides features that were traditionally provided only by very expensive hardware. Its high-speed interface can be used where interconnections to the target require long cables and very low noise. Here's a graph showing Microchip's hardware debug systems from the lowest cost PicKit 2 through the PicKit 3, MPLAB ICD3, and MPLAB RealICE. These debuggers provide a continuum of tools for almost any budget. All devices perform basic debug functions. All offer 2-wire programming of devices in circuit. Features and performance improve as you go from the left to the right in this chart. MPLAB starter kits offer simple demonstrations and interactive learning for dedicated applications. These easily hook up to the PC and run interesting demos right out of the box with no programming required. MPLAB starter kits offer built-in debugging and programming to provide a learning experience for the novice, or to get a professional quickly up to speed with the new technology. Each starter kit requires only a USB connection for power and communication, so they are easy to set up. The demonstration activates immediately upon connection to the PC, offering simple out-of-the-box use. Included are tutorials, projects, source code, and a custom version of MPLAB that is automatically loaded with projects to demonstrate the technology. MPLAB starter kits have integrated debugging and programming so that you can single-step through the demos to understand the code. You can even modify the code to see what effect it will have on the demonstration. There is no need to buy an additional hardware debugger or programmer for use with the starter kits. Starter kits are very low cost, aimed at bringing the technology to you as affordably as possible. A wide range of demonstration, learning, and proof-of-concept PC boards are available to jumpstart an application built around standard hardware. These systems come complete with firmware, source code, schematics, and reference designs that can be used as models for your design, and as a starting point for exploring development with Microchip devices. These systems usually provide breadboard areas for you to add additional custom circuitry. The firmware can be modified in MPLAB and reprogrammed by MPLAB's other hardware debugging and programming tools, such as MPLAB ICD3. So, in summary, we'd like to answer the question, why Microchip tools? Microchip has long been noted as having a strong commitment to development tools. Without good tools, embedded systems design can be frustrating. Our tools have these advantages. The Development Systems Group is dedicated to high quality. Our processes are certified to ISO 9000 and are audited yearly to ensure that our quality improvement process is helping us produce and maintain robust tools. We have quick delivery. Order tools through your local distributor, via the internet, or buy on our website. Most software tools can be downloaded immediately. Microchip has free technical support. No credit card fees are required for support. Our staff of corporate application engineers has years of experience with embedded systems designs. We also maintain web conferences where users can post questions and get help from their peers and development systems engineers. If a tool develops problems, we have a quick turnaround service authorization request program. Our goal is 48-hour turnaround. Because Microchip makes the tools for our silicon, you are assured that there will be no finger pointing when and if there are problems. The buck stops here, and we're dedicated to solve your problems and assist you in getting your design out the door. Last, our tools are world-class, yet still reasonably priced. For quality, availability, support, service, and value, Microchip Development Systems provides a cost-effective solution for your embedded design projects. If you haven't already done it, now is the time to get started with MPLAB IDE. Simply go to our website at www.microchip.com/mplab to download your free copy of MPLAB software. This is the end of our presentation. Thank you for your time.